I've just turned on my video on for a second. I want to say hello to everyone. I can't see you, but I feel somehow better connected. So to save bandwidth, though, I'll turn it off again as we get this started. So welcome, everyone. Thanks for joining.
You are all set to go.
All right, Missy, thank you. See that I can advance the slide here, just like we practiced it. Perfect. The quick commercial here at the beginning is just to say, if you're not familiar with Caloris, we are a supplier of new equipment and upgrades related to evaporators, spray dryers, membrane filtration, and that's mainly for the food, dairy, and beverage industry. So if you have any questions along those lines, please reach out to us, and we'd be happy to help you. As Missy said, we're recording this. You get a link to the recording. Please feel free. Consider this verbal permission for you to use this for your own uses if you find that it's useful to you. The link will remain on the Caloris website, and you can always go out and get it there. Otherwise, you'll have it emailed to you, I think, in 24 hours. I always like to take just a minute for a safety discussion at the beginning of a presentation like this. You know, we are talking about spray dryers, and specifically today, baghouses. These have all the conditions necessary for fire and explosion. The pentagon in the lower right of this slide. We have oxygen in the air. We're moving through the dryer. The product we're spray drying acts as the fuel. It's in a confined space. It's dispersed in a cloud of powder. All we're lacking is the ignition source. So we say to you wholeheartedly, please stay vigilant with the plants you're supporting. Help them to stay vigilant if you're not able to be there, if you're still social distancing from your plant. We would highly recommend, and sometimes the baghouses are forgotten, or dust collectors that are maybe around your spray dryer but not directly related to it. If you have any of these safety systems, a water deluge system, spark detection system, CO monitoring, perhaps an explosion suppression system, test them regularly. I repeatedly go to plants and ask, and I don't get the firm answers of, oh yes, we test this monthly, or oh yes, we test this every 6 weeks. If you have responsibility for a spray dryer or baghouse, those answers should be known to you, that you are testing your systems. If you have overpressure vents or overpressure doors, do check that those can open and swing freely. When I ask people, hey, have you had problems with those? Yeah, we have had some problems. We've caulked them. Or the shear pins are held with bolts now. Those are all kind of scary answers for folks like me. And we're happy to help you with that. If you have questions in those areas, we can either make that a topic of another webinar in the future, or just reach out and we'll be happy to talk you through what we think a safe condition for your spray dryer is. So with that, I'll move on to the topic of the day, which is baghouses and troubleshooting. So the first thing I want to be clear about, a baghouse is a filter. So when we talk about this filter, we want to talk about the filter media. We all look at the big stainless steel can that is the baghouse, but it is just that, it is a filter housing. The stainless steel can only affects the filtration so much. It's definitely important to the design. We'll talk in a few minutes about air to cloth ratio. But the function of the baghouse is a filter, and therefore the cloth or the filter media is definitely the thing we're talking about here when we talk baghouses. If you need a little reference source after this, the Industrial Gas Cleaning Handbook from the International Series of Chemical Engineering, I guess it's volume 8, is a good resource for real sort of scientific, technical issues with baghouse, or you want to know the science a little bit. You know, they headline it under tackling a gas cleaning problem, and these sorts of parameters are the kind of things they're going to want to know. We'll discuss a little bit more here today. So baghouses is part of a spray dryer. If we're going to troubleshoot it or talk about troubleshooting, we need to identify the types of problems we're going to do. I mean, we could go on for days having discussions probably about the various problems you've seen. We're going to hit a couple of highlights here. So high pressure drop in your baghouse, that's choking the airflow, perhaps reducing your dryer capacity or preventing you from increasing capacity. So high pressure drop is one area we'll talk about. We'll talk a little bit about emissions problems. So that could be from broken bags, poorly sealing bags, prematurely wearing bags, but all related to powder getting past your baghouse and out your roof, creating an emissions problem. We'll talk a little bit about product release problems from the filter bag. So we're collecting your product in the bag house on the filter bags. And in most cases, that is saleable product for you and you want to collect it. So we'll talk a little bit about that. We're not going to hit so much product not exiting the cone so well, whether it's your drying chamber or a cyclone or a bag house. Cone flow problems are another topic, and we would handle separately. So apologies if you joined looking for that answer, but feel free to reach out directly if there's something you want to discuss. So what makes a bag house as part of a spray dryer unique? I'm going to go over the principles a little bit. This, all in all, a bag house on a spray dryer is a high moisture application. So what do we mean by that? It means that in every kilo of air, so I'm going to use kilograms and grams. So in every kilogram of air, there's about 40 to 100 grams of water as it in the air, leaving the drying chamber and going to your bag house. And all in all, that's pretty moist. That would be considered a high moisture application. Now, those numbers there are pretty product specific. So one product may run at 40. That could be something sticky powders, something with a lot of carbohydrate in it, something with a lot of fat in it. Where the higher numbers, like 100 grams of water in every kilogram of air, could be your more proteinaceous, high protein products. But so the number you're actually going to run on your spray dryer is not going to be a wide range like that. It's going to be a specific number that's related to your product. But across food products, you're going to see a range that looks like that. So 40 to 100 grams of water in every kilogram of air. And what does that equate to? That equates to about 10 to 20% relative humidity at the dryer exhaust temperature. So your dryer exhaust temperature may be different. It may be 160, it may be 200, but generally it's that range of 10 to 20% relative humidity. Now you may say, geez, 10 to 20% relative humidity is not very high. And you're right. I mean, if it's a day where you're walking around outside and it's only 10 to 20% relative humidity, it's going to feel dry. But at 180 degrees, what you are at is near the sticky point of the product. So whether that's scientifically the glass transition temperature, because you have a carbohydrate type product, or it has to do with thermoplasticity that may be more related to fats or proteins, you are near some point of stickiness. A little more humid and your product will stick a lot, whether that's clogging up cyclones, sticking to the fabric of your bags in your bag house, or not flowing out of the bag house. So for spray dryers or these sorts of high temperature applications, for the products in sort of this food classification that we're running, 10 to 20% relative humidity is fairly high. And that's what makes the bag house that's part of a spray dryer a bit of a different beast, a bit of something special. So why a bag house? What does it do? Let's not be confused about its purpose. One, it's meant to capture your product. So if you can use it as saleable product, maybe you have no cyclones, maybe your bag house is directly connected to your drying chamber, then all of your product is going to get captured in the bag house. But the purpose is to capture the product for your use and probably sale. The second thing it does is it helps meet emissions requirements. So we can do two things in one item, in one vessel within the process. If we couldn't, maybe we'd use a bag filter to capture the product and have to put a wet scrubber after it to capture to meet the emissions requirements, but we don't. The modern fabric of modern bags can do these things both rather well if they're applied correctly. So filter bags, again, we said at the beginning, we're going to focus on the filter media a little bit. So again, the Baghouse is a big stainless steel can, and we are going to focus on the filter bags that this is a filter holder for. So in the food industry, it's mostly 16-ounce polyester felt. There are times when people try lighter fabrics, 12-ounce polyester felt. Those often wear quicker. The industry sort of settled on the weight of 16-ounce polyester felt. If you were changing bags for other reasons more often, because of allergen considerations or other considerations, maybe you're changing bags every month. There's not many people that do that, but if you were to, then you could consider a lighter fabric. There are other materials. The food industry would accept 16-ounce acrylic felt. There might be reasons to try acrylic, but it's not for release characteristics. It's not for wear characteristics. Have had some success with using acrylic felts in the dry out of CIP-able baghouses. So for special applications. Now we can have special surface treatments, heat treated surfaces, singe surfaces of the polyester felt. There can be membranes like Gore-Tex or an expanded polytetrafluoroethylene membrane like Gore-Tex that can be on the bag or between the layers of fabric. There can be destaticized bags if static electricity is an issue. So there's a whole range of different bags. And again, not all bags are the same. Not all have the same quality, and quality can take different forms. It can be filtration capability, it can be release characteristics, it can be durability. I've seen the same bags, from one vendor quoted at $10, where that might be the type of bag in an easier application, where the same bag, 6-inch diameter, let's say 12 feet long, 14 feet long, might be $40 if it has membranes associated with it or the rest. But the goal is to find the right fabric and the right filter, therefore, for your application. So low-cost bags, hey, don't get me wrong, they work. But they're good for when the air is cool and dry. That might make them good for a nuisance dust collector. That might make them good if you have a fluid bed baghouse where you're just getting that low moisture, medium temperature air out of a fluid bed. But in a spray dryer with the conditions we talked about earlier, it might be a challenge. The inexpensive bags might be a challenge, both from a wear standpoint, because ordinarily maybe you should be getting 6 months, 9 months, or a year out of your bags, or for filtration characteristics or release characteristics. To the other end of the spectrum, expensive membrane bags. Some people think more expensive is a little better, especially when they're deep in it on trying to solve a problem. Maybe you've changed formulations. Maybe you're trying to push capacity, whatever your challenge is. But membrane bags aren't always needed. They're not, the bigger hammer in this case, the more dollars, is not always what's necessary. It doesn't always guarantee a better result being better airflow, better release. So really, inspect, ask yourself, why am I leaning towards a membrane bag? Why do I maybe use one today? Do I need to spend that money? And you could find the answer. There could be an answer in that of a little bit of cost savings or confirmation that you're using the right thing. Beware cheap knockoffs. I've seen people put things like membrane bags in. They're like anything that comes from, let's say, countries where they're new to their industry and new to quality control procedures, that you could get something that's a little more difficult. I've seen membrane bags where there's been too much heat treatment, too much ironing, so to speak, of the membrane onto the fabric. And although it's Gore-Tex and it should have, a billion little pores in it, the heat treatment was too much and it ironed all those little pores closed, melted them closed. So be careful of that sort of thing. Do get your filters. They're important. Get them from a good, reputable vendor. Where maybe they've gone out and had them tested, or you have gone out and had your bags tested by an independent laboratory. And then remember, the membrane bags are not always good for all additives. One that comes up time and time again, especially in the dairy industry, is the adding of lecithin to the product. So as lecithin as a coating, not lecithin as an ingredient, but lecithin as a coating. Sprayed on lecithin could have some lecithin buried in the air and make its way to the baghouse, and that just blinds them over. That ends any good release characteristics you may have from the bag of fabric, and will blind them over. So do be careful if you're considering additives or you have additives, especially things like lecithin that are coatings. Baghouse is part of your spray dryer. Going back to design principles, just a moment for a few minutes for design principles. A baghouse is designed and sized based on an air to cloth ratio. That's the amount of air moving through your spray dryer and going into your baghouse. So the air side of it, the cloth, is the number of square feet of cloth. Remember, this is not a product to cloth ratio. It's the amount of air. So you could have all your product, you could have a dryer where there's no cyclones, all your product goes direct from your dry chamber to your bag house. You could have a very heavy loading. Sometimes that works better when you don't only have fines. So, and do remember it's ACFM actual cubic feet per minute. So it's calculated at the air density for the actual temperature. If you're plant at altitude, make sure to take the air density of your altitude into account, so temperature and altitude, to calculate an ACFM for the air going into your bag house, and then a number of square feet of cloth. You can calculate your 6-inch bags and how long they are, and then how many total square feet of cloth you have in your bag house available to act as your filter. So different kinds of bag houses. Just a little comparison here. So up in the top of the slide, I've written, I've taken a dryer, just an example I chose to use, 7,000 pounds per hour of powder produced. That type of dryer uses about 100,000 pounds of air. And that air, that would translate, because we're trying to make pounds of product from pounds of air, that's why those two are related. But we want to correct it to the actual CFM. So I've got a plant at sea level. I've got dryer exhaust air at 180 degrees Fahrenheit. I've used an air density to calculate the actual CFM to be 25,600 ACFM. And I can choose from three general classes or three typical types of bag houses. On the left side, I'm talking about a rectangular bag house. It might be mild steel, it might be stainless steel, don't know. You have air coming in the bottom. I call it a spud inlet. It's just a duct poked into the side. And if you had a bag house like that, you'd want to design, I would be designing, for an air cloth ratio of about 2-to-1 or 3-to-1. So a lot of filter bags, because it's an inexpensive bag house, rectangular, and the like, possibly mild steel, but it's going to be bigger, and you're going to have more work. So a bag house like that for 25,000 CFM would need about 850 bags, 12 feet long. We move on to the middle case, and we're looking at a round bag house. So maybe it's stainless steel, maybe it's mild steel, but it's round. It still has a duct poked in, but maybe it's aimed upward, or maybe it's in the mid-side wall. So not the gentlest entry of the air, but now a round vessel that has a little bit of cyclonic benefit in the rest. And we'd be talking about, I would be designing for something like a 4-to-1 or 5-to-1 air to cloth ratio. Again, for typical food powders, dairy powders, flavors, things like this, across the food industry, other commodities, proteins, things like that. Now that same bag house on the same dryer would be down to about half the number of bags. It'd be down to about 475 bags. So we move on to something a little more state-of-the-art. So still a round bag house, but a tangential inlet. So the air is entering cyclonically, and not only is it entering cyclonically, it's entering as high into the bag house as possible, so that the net movement of air is downward, the same as we want the net movement of product to be downward. With the other bag house, the net movement of air is upward, while the movement of product is downward. So in the round bag house with the tangential inlet, on the right, I'd be designing for an air to cloth ratio of maybe 6-to-1 or even 8-to-1, depending on the characteristics of the specific product. And that bag house would be down to 280 bags. So you can see the design of the bag house has a little bit of play into it, both if you're building something new, bigger bag house versus smaller, or if you're trying to maintain it, so changing 850 bags each time versus changing 280 bags each time. So a little bit about how we choose them and select them, and why you may have in your plant what you have. All right, so troubleshooting now. Let's dive into it. And troubleshooting being high. First one we talked about was high pressure drop. So if you have a high pressure drop in your bag house, again, typical design, I might say, okay, clean bags, you're going to have, you just put the bags in yesterday, you're going to have a lower pressure drop, maybe only 1 inch of differential pressure between the bottom product plenum of your bag house and the top clean air plenum of the bag house. So the differential pressure we're talking about between the dirty side of the filter and the clean side of the filter, the product side and the clean side. Bag houses and dryer manufacturers across the board, whether it's Caloris or some of the big guys or some of the small guys, they're probably designing so that you level off at 4 to 6 inches of differential pressure. So that's 4 to 6 inches of water column, as measured on a pressure gauge, not PSI, inches of water column is measured by pressure gauge, 4 to 6 inches as a good operating range. And if you were higher than that, 9 inches, 10 inches, 11 inches, you would be calling that a high pressure drop and an indication of a problem. If you have that problem, the first thing I want to check, if I'm coming into your plant, you invite me in and call me up, I'm going to ask, is the instrument reading correctly? Time and again, it happens. I mean, calibration is a challenge. You run you run a plant that's, an industrial environment, it's difficult, and sometimes instruments are missed. But is it calibrated correctly, and is it working correctly? If the product sensor side, so perhaps a little piece of polyflow that's coming from a measurement point, on the dirty side of the Baghouse, if that's plugged with the product, you're going to get false measurement. So do keep an eye on that. Compressed air, another easy thing to eliminate as a problem. If you're having problems, make sure your compressed air is working correctly. Compressed air for reverse jet pulsing. Make sure there's not moisture in the air. Make sure there hasn't been moisture in the air recently. I know good plants that have good air compressors, good desiccant dehumidifiers, but all of a sudden, last week, for 15 minutes on the Saturday night shift, they had a problem. And moisture got into the compressed air system, and now that's been pulsed into your bag, so they got coated during that because of that interval, because of that deficiency. So it's not only that it could be continuously have moisture, but do search for those occasional upset conditions where you may have had that. Do keep an eye on your solenoid maintenance. If you've got reverse jet pulsing, again, it's common. I'll come into a plant, we'll try to troubleshoot, and out of 20 solenoids, 2 or 4 or more haven't had their diaphragms maintained in a while, and they're not pulsing correctly. The solenoid, maybe the electric part of the solenoid may be working, but the pneumatic side isn't. So that's a significant amount of loss of area in your baghouse if 4 solenoids out of 20 aren't pulsing correctly. So do keep an eye on that maintenance. Do keep an eye on the timing sequence, the amount of time that your solenoid is open. That might be 0.2 or 0.4 seconds. And do keep an eye on the space between pulses, so that whether you're pulsing a row of bags every 10 seconds or every 40 seconds, it'll be custom to your operation. You want to use as little compressed air as possible, but do know what it is so you can see if something's changed. High pressure drop could come from an increase in airflow. You would think we would know if you had an increase in airflow. You pushing your supply fan, you got to change the supply fan, reshift it, whatever you're trying to increase capacity. But high pressure drop would definitely be the big culprit would be an increase in airflow. And then finally, like I said earlier, additives like lecithin. If you bring lecithin into a fluid bed trying to make an instantized type product, lecithin getting carried over in the exhaust air, carrying over to a baghouse can really blind those bags over quickly, especially membrane bags. So a few tips on the simple tips, reminders probably on what could be going on with high pressure drop in a baghouse, and at least what high pressure drop in a baghouse means to someone doing troubleshooting. Remember, okay, we'll move on to emissions a little bit. Remembering that a baghouse is part of the process. The baghouse itself has mechanical aspects, that physical aspects that deal with emissions. So that's the filter bag sealing correctly into the filter housing. So the filter bag sealing correctly into the tube sheet. If that doesn't seal correctly, you'll never not have emissions problems. The bag filter durability. So if your either threads are breaking up at the collar of the bag, or seams are breaking along the side of the bag, either because of pulsing or because of wear against the cages. That's the kind of mechanical or physical aspects that could be going on. It could be causing emissions challenges, and also the process aspects of the fabric itself. So either your emissions are going through the good parts of the fabric, or your emissions are going around the good parts of the fabric. So that's what I want to talk about for a couple of minutes. So baghouse emissions, product particle size has the most to do with emissions. If you are making more small particles, if you're having a finer spray, you're running higher pressures, you've reduced solids, you're you've reduced viscosity, somehow changed your formulation. If you make more small particles, you are going to have more emissions. If you can make more larger particles, less product is going to either make it to the baghouse or certainly make it through the baghouse. So if you have smaller particles, you're likely to have more emissions. So do know that you understand your particle size distribution. Maybe you do screening tests with stacks of screens to see your particle size distribution. If you start making smaller particles, you're going to have more issues. So again, part of the troubleshooting process is to, when things are working well, to know what you're making, and then if you develop problems, know how you've deviated from what you're making. What you make, when you've started a dryer, or right now, maybe make a benchmark now because you know it's running well now, so you can find out if you've created a deviation. Bags sealing to the tube sheet. So you get a new baghouse. We got to make sure, we as a supplier, we have to make sure that we have all the holes around, and that's a pretty tight tolerance thing. We have to make sure they're all the right size, so that the first time you get this filter housing that we call baghouse, you have round holes of exactly the size you expect them to be, because the bag manufacturer can replicate. They make thousands of bags, tens of thousands of bags, and they can stay within tolerance. So we just have to make sure those two things match. You need to know about felt fabric. So how the cuff go on at the top? What's the thread made out of? How durable is the thread that is sewing the bags together? Are they single sewn or double sewn? So that you get that good seal at the top. We want to make sure the bag diameter is right. So if we're going to have 6-inch bags, that we know if it's 5 and 15/16 bags or 6 and 1/16 bags, but that you have those bags and you know exactly what you're buying. You buy the same thing every time, so that those snap rings on your bags snap in just as you expect them to, nice and easy every time. Little diagram of bags and cages, just to lead into the next bit of the emissions conversation. So you have a tube sheet. We're showing 2 bags here. I'm showing the Venturi horn on top of the tube sheet, standing upright. You could have them maybe as an integral part of your cage design. That's not so much USDA design for dairy plants, but definitely in other food applications, definitely possible. You have a filter bag, 6 inches in diameter, hanging down. Maybe it's 10 feet long, 12, 14, 16 feet long, hanging down. And we put a stainless steel cage inside of it to give it some shape so that we maximize the filter area. I wanted to mention earlier, I'm just remembering it now, there are often, in very small baghouses, filter receivers that are part of conveying systems. There are bag cartridges. There are some applications where cartridges, so pleated cartridges, are good applications, and they are available long, and they do have a lot of filter area. But I find them, my personal experiences, I find difficult in a spray dryer environment, exactly for those moist, sticky reasons we talked about earlier. So a dry, cool, moisture-free, low humidity environment, cartridge filters, a great solution. That's a vital and rightful application. But in a spray dryer baghouse, very few times. I'm not saying I've never seen them work. I'm saying that very few times I've seen an application where a filter cartridge will work, a pleated filter cartridge will work in a baghouse. Also wanted to mention there's somebody who's trying to make some more surface area out of every 6-inch tube and have created star bags. So they look like a 5-point, 6-point, or 7-point star, where in between the wires of the cages, the bag billows inward a little bit. And you get more surface area that way. I've seen release, irrespective of the fabric, I've seen release characteristics, release problems, product release problems with those. So do beware of those. Know if you're going to experiment with them, to keep a close eye on things. Again, I'm not saying they never work. I'm just saying they're difficult in a spray dryer oftentimes. So the most important part, as we show this diagram here, is we've got to get the seal. There's only one place where the filter fabric touches the stainless steel hole, and that's at the snap ring. A very common type of installation in spray dryer baghouses. So right in there, that must connect. That is the only place you're going to get the seal and the only place you're going to prevent emissions. So if your filter house, your Baghouse stainless steel manufacturer gets your Baghouse right to start with, and your bag manufacturer keeps making you the same bags, you're going to get a good seal there. Again, color coding it a little bit. This is what it looks like. We're showing you a bag in sort of yellowish green, the stainless steel cage. The cage is not the seal. The bag is the seal of the fabric to the tube sheet. The cage sits over it and gives it shape. The venturi horn sits over that and allows the compressed air to work in the most efficient way possible. And it's all held down onto the tube sheet and pressed in place by a hold down mechanism. But please make no mistake, it is the seal of the felt bag fabric to the tube sheet that is holding your emissions at bay. So looking at the fabric itself, I'm going to show you just two fabrics, but the point I want to make is that this sort of data, there's a lot of data available from your bag manufacturer. You should ask for it, get their opinion on what their bag means to your product in a spray dryer. So this is a very standard 16-ounce data from a very standard 16-ounce polyester felt bag with an eggshell finish. So it has a little bit of a heat treatment on the exterior. They call that an eggshell finish to try to improve release characteristics. There is a size range of particles that's micrometers there, so very small particles, 0.3 to 0.5 micrometers in the size range part of the table. Even the largest particle that the fabric is tested against is no larger than 5 micrometers. The average spray dried particle is 50 to 120, so this is absolutely the finest dust. This chart says on its lowest line that initially, under initial conditions, absolutely clean fabric, you've just put it in, you're going to capture 92% of the particles that are 5 micrometers and larger. That's going to be most of what you spray dry. And once the bag has a little bit of a coating on it of your product, it's going to capture 100 of it. 100% of the product you're getting in there. And it's only as the particles get to the very small end, the finest smoke-like dust particles that you produce in your spray dryer, and you do produce some, only those will go through the fabric. So a pretty typical fabric that's used in a lot of spray dryers, a lot of applications, dairy applications, whey applications, cheese powders as you get into other flavors with carbohydrate carriers, with salt-based carriers, a typical type of fabric to use in a baghouse. And a cost-effective one as well. Don't think we're not thinking along those lines. Another type, same chart, the fractional efficiency you can see is quite different. This is same 16-ounce polyester felt. To you and me, when we grab it and touch it, it will look the same and feel the same. But when you run this and the fabric is clean, you're getting a lot more of your product. And once the fabric has a coating on it, I mean, it has a coating within minutes to an hour of operation. It has this 0.2-inch coating. You're capturing a whole lot more. So if you have tight emissions guarantees, that sort of thing, and generally average requirement for release characteristics, you don't have a terribly sticky product. So terribly sticky, I'm talking about beyond whey permeate, beyond some of the maltodextrin products, really, really sticky. Beef flavors I consider really sticky, those sorts of things. Cheese powders can get really sticky. If you have those kinds of things, I might be going and looking at a membrane in the fabric. But this coating, this microdenier type of standard 16-ounce polyester is the type of thing I would look at if I was trying to meet very tight emissions guarantees with sort of typical food product. So what I wanted to show by showing you the two tables, I'm going to slide back to the previous one just so you can look at it. Polyester, you can see the numbers on the right side of the table. You can see here they change for the microdenier fabric. There are differences in the fabric. That's the point I'm trying to make. And if you're running a plant and your emissions guarantees, your emissions permits from your local regulatory authority rely on the quality of the fabric, This is the type of information you should have if you're inviting someone like me out to troubleshoot your plant. It's information I'd like to know. What bag you have in, any data you have from it. Have you sent bags out for independent analysis? Especially if they have coatings like Gore-Tex or PTFE membrane. Do you have data from any independent tests that show you have bags of quality to collect both your product and meet your guarantees? So I'm just over my half an hour, so I'm going to say thank you very much. If you do have questions, Missy monitors the info at Caloris, and you can reach us that way. I gave my email address at the beginning. You can always check the Caloris website. And Missy, with that, I give it back to you and let you moderate any questions we may have had.
All right, thanks, Jim. And I want to apologize to folks. I know we had a little bit of sound quality issues in the middle of the presentation there. So now is the time that it seems like the audio has resolved itself. If you feel like you missed anything during the middle there, and you want to ask a question using the Q&A feature, feel free, because we've got plenty of time to answer questions. In the meantime, I do want to let you know that we have a couple more upcoming webinars. You see the one mentioned here on this last slide on Thursday, July 16th. We'll be discussing when to replace your membranes, and Gary Maxson, our membrane specialist, will be the speaker that day. And you can register for that at caloris.com/caloris-webinars. And I can also tell you that on July 30th, we'll also do a webinar, and that one will be on TVR evaporators with Bruce Skinner. And that's a topic that was actually suggested by one of our audience members wanted to learn more about that. So we are always looking for suggestions for future webinar topics, and you can send those to that info@caloris.com address that Jim mentioned earlier. If you want to be among the first to know about our upcoming webinars and you're not already receiving our weekly e-newsletter, you can join our mailing list by scrolling down to the bottom of any page on our website, and you'll see a prompt to enter your email address. And again, we only send out one email per week. It's a industry e-newsletter with resources for plant managers, market and industry news, and announcements such as our webinar series. I haven't seen any questions come in, and again, I apologize for the sound quality in the middle of the presentation, but if you have any questions that you don't feel comfortable submitting in the webinar setting, you can always feel free to use that info@caloris.com address, and I can forward that. That goes directly to me, and I can forward your questions onto Jim or whoever the appropriate person is. And with that, please feel free to ask us anything right now, or we will hope to see you on a future webinar.